Okay, so actually the easier of the two between independent and dependent is the independent events. Now, again, what you're really going to have to, I guess, be conscious of is it independent or dependent? Because if once you figure that out, you'll be able to go down the right road of how to solve it. Now, for independent events, I want to just go down to the key ideas. Now, an independent event means the first event does not affect the second event. Okay, so here's an example. Tossing tails with a coin and then drawing an ace of spades from a standard deck of 52 cards. Okay, last class we pulled a card and kept it out. Now we're not out of 52 anymore, we're out of 51. That first card and putting it out, now it affects the second draw because I have less cards. But you know, flipping a coin and then you're about to pull a card, do you see how they do not affect each other at all? Okay, they're independent. And for independent, all we have to do is do the probability of A times the probability of B. So what's the probability of getting tails? 1 out of 2. What's the probability of getting a spade, ace of spades? It's ace of spades. Yeah, so if it was drawing an ace, it'd be 4 out of 52. So where? 1 out of 52. So that would be 1 over 104. Okay, so this is kind of a nice way to end a unit, right? Because it's very straightforward. Sometimes they're not so straightforward. I'll be the first to admit it. This one I'm pretty sure is. Okay? Now, it's always, to me, if I was in your shoes, I'm like, okay, what kind of different questions are they going to ask? Is it always just putting it in formulas? Or are they just going to, they will just maybe ask, which of the following is are independent? And you'd have 4 things to read. Okay? Now, let's do some examples. Now, in each situation, classify them as either independent or dependent. Now, if it's dependent, the first event affects the second. Okay? Now, we've got a 4-colored spinner spun and a die is rolled. The first event is spinning red and the second event is rolling a 2. Is that independent or dependent? Independent, right? Why? The roll doesn't affect the spin. Right? Or vice versa. Okay, a red die and a green die are rolled. The first event is rolling a 1 on the red die, and the second event is rolling a 5 on the green die. Independent or dependent? Independent, yes. The red die doesn't affect the green die. Okay, 2 cards are drawn without replacement. Like, you just need to stop there. Okay, that's dependent, right? Okay, and then it's without replacement. That means the second time I go in to pick a card, there is less cards. The first event affected the second event. Now, there are 30 cards numbered 1 to 30 in a box. 2 cards are drawn 1 at a time with replacement. Independent. Here is your Okay? And once again, will there be people in that diploma that do not know the difference between independent and dependent? Absolutely. Okay? So just every more you know gives you that much more of an edge, right? Yeah, you do have to know your definitions, and you have to know what really, like those key words, right? Like I want you to be so confident when you see without replacement dependent. Okay? Okay. Now, this is a really tough question, unless you do a tree diagram, and then it's pretty cool. Okay, the next two, because once you see how to do them, they make sense, and they're not so hard. If you've never seen how to do these, they're pretty well impossible. So Anne and Chantel are playing a die and coin game. Each turn consists of rolling a die, a regular die, and tossing a coin. It's independent, correct? Points are awarded for rolling a 6 on the die. So you get points for rolling a 6 on the die and or tossing heads with a coin. Okay, so 6, that's awesome, and heads. Okay, that's good. Now, you get 1 point for either outcome. That means I get a 6 and tails, or I get 1, 2, 3, 4, 5 and heads. As long as I get one of these, I get a point. You get 3 points if you get a 6 and heads. And you get 0 points if you got neither. So 1 tails, 2 tails, 3 tails, 4 tails, 5 tails. That would all be bad, right? No points there. Is everyone with me how we're going to get points? Now, players alternate turns. The first player who gets 10 wins. Now, determine the probability that Anne will get 1, 3, or 0 points. Now, this is a hard question, okay? So, if you get 1, 3, or 0 points on her first turns, on her first turn, okay? So again, this is a super hard question, but maybe when you see this, okay, so first of all, we're going to talk about rolling a die. Now, we've got rolling a die, we've got the a win is if you get a 6, correct? What are the chances of getting a 6? 1 out of 6. What are the chances of getting a, now what's this called? That's not 6. 5 out of 6. Does this make sense? Yes. Okay. Now the next thing is tossing a coin. Okay, so you've got your, so this is actually the probability of getting a 6, right? Or not 6. So what's the probability of getting heads? Probability of getting tails, which is not heads. Okay, so what's the probability of getting heads? 1 out of 2. Probability of getting not heads? 1 out of 2. Okay, then I could get a not 6 and heads or tails. Okay, and that's 1/2, 1/2. Now, the probability of getting a 6 and a heads would be 1/6 times 1/2. Right? Because and means, what does ands always mean? Multiply. Or always means add. Okay? So this is 1/2 times, so I'm going to write it here instead of just the answer. So this is 1/6 times 1/2, right? I just multiplied this whole line together and I get 1/12. Now the probability of getting 6 tails would be 1/6 times 1/2 again, right? Just 1/12. Now what's the probability of getting anything else but 6 and heads? Would be 5/6 times 1/2, which is 5/12. And then 5/6 times 1/2, this is, I am getting anything but a 6 and tails, would be 5/6 times 1/2 is 5/12. Does this make sense? Okay, now, how many points do I get for 6 heads? 3 points. So does everybody agree this is 3 points right here? Okay, because this is 6 heads, right? How many points do I get for 6 tails? Okay, so this is 1 point for 6 tails. Okay, how many points do I get for not 6 heads? 1 point. So that's not 6 heads. And how many points do I get for not 6 not heads? Does that make sense? Okay. So now it says determine the probability that Anne will get 1, 3, or 0 points on the first term. Okay, what would you expect? Okay, didn't they just name every scenario basically? Yeah, okay. But let's change it to so let's just ask some questions you might get on the problem. What's the probability of getting 1 point? So that would be 1/12 plus 5/12, which is 6/12, which is 1/2, which is 50%. Okay? Well, no, that better? I'm here to please. Okay? But that's the kind of question they could ask. So just make sure that these, so if independent will always equal 1. And you can try it 5, 10, 11, 12. 12 twelfths, right? You have a 12 twelfths chance of getting at least one of these. Okay, so anyway, we'll just finish this off. The probability of getting 3 points is 1/12. Probability of getting 1 point. Yep, that's why I can write it down. And the probability of getting no points is 0. Oh no, 5/12. What are you talking? Who was I listening to? U7. See? When will I learn? Okay, does this make sense? Again, once you're kind of shown it, you're like, oh, okay, I could do that now. But I think if I would have left you guys and said, okay, figure this out for me, if I would have said, okay, what's the probability of getting 1 point? I don't know how that would have went. Okay, now the next question is very, very typical of a diploma question. And this one, again, you got to use your tree diagram. Now we have 1,000 tickets for a charity raffle, been sold and placed in a drum. There will be 2 draws. The first draw will be for a grand prize and the second draw will be for a consolation prize. After each draw, the winning ticket will be returned to the drum, so it might be drawn again. Max bought 5 tickets. Determine the probability in the nearest tenth of a percent that he will win at least one prize. Now, there's 2 ways to do this. You can do the independent route or the dependent route. Which route should I go? Why independent? What? Because of this line right here. This means independent. Okay, so they'll have both answers for you ready on the diploma to be able to do this. Now, here's where it gets, what is the probability that he will win at least one prize? So, what does that mean? What are the 2 prizes called? There's the grand and the consolation. So that means, can I win both? At least one means I won both. I could win both. Right? Like if you won both, Yusuf, I said, how many did you win? You're like, I'm telling you. And I go, did you at least win one? You could say yes, could you? Yeah, you can. So at least one is still 2. Okay? Now, that means also, that means plus, so I win both, or I win grand, lose consolation, or don't get grand and get consolation. So, here's grand. Now, we got probability of win and probability of losing or not winning. It's a lot more positive to say not winning. You're such a not winner. See, that doesn't hurt. Like, well, I guess not. Okay. Yeah. What is the probability of winning the consolation prize? Yes, he's having a personal argument over here with himself. Okay, what is the probability of winning? Okay, so it is 5 out of 1,000, right? Which, if you reduce it, that's 1 over 200. Okay, I'm going to put 1 out of 200 after I put that. If I would have went right to 1 out of 200, I would have lost a couple of you. So therefore, with 1 out of 200 of chance of winning, what are your chances of not winning? 199 out of 200. Setting up this chart is extremely vital. Austin, make sure you write this down. Now, then the next is the consolation. Now the consolation, this way. Now can you use the same tree diagram for dependent? Yeah, you could. It's just you're not going to, the next one's not going to be out of 200. It would be out of 199. Correct? Because you didn't put that ticket back. In fact, no, it wouldn't be. Because you had 5 out of 1,000, so you'd have 5 out of 1,900, or no, 999, right? We have to take 1 minus the 1,000, not the... Oh yeah, so you'd have 4 out of 999, which doesn't reduce. Okay? So, but since we put it back, it is independent, so I now have a 1 out of 200 chance of winning, and 199 out of 200 chance of not winning. And then again, I'm going to do my probability of win, probability of not winning, and you'll see that these will be the same. And then again, to now find out winning, you multiply them together. So that's 1 out of 200 times 1 out of 200, which is 1 out of 40,000. Okay, and if you, now what's the probability of winning grand? So this is, remember, you got grand prize and consolation. That is one lucky day. So you have a 1 out of 40,000 chance of winning both. Okay? For not, so you win the consolation, which was 1 out of 200. But, no, sorry, you win the grand prize, and lose consolation is 199 over 200, which is 199 over 40,000. Okay, so that's grand and not consolation. Okay, now what's the probability that you lose the consolation, which is 199 over 200, and you win the consolation, 1 out of 200. So that again is 199 over 40,000. Because that is, didn't win the grand and you did win the consolation. And now, what is your probability of not winning the grand and not winning the consolation? You can see that one is the most likely. So 39,601 over 40,000. So, and that's not grand, not consolation. So the question was, what is the probability he will at least win one prize? So that would be grand consolation plus grand not consolation plus not grand consolation. Does that make sense? Because that's at least one. So that would be 1 out of 40,000 plus 199 over 40,000 plus 199 over 40,000, which equals 399 over 40,000. Remember, we do not add the denominators. Okay? And if you work that out, it's 0.009975, which when you add the decimal 2, it's 0.9975%. Okay. Now, there's another way to do this one, and that's by using the complement. Now, the complement, what is the opposite of winning at least one? Winning nothing. So if you go 1 minus lose both, that is 1 minus, okay, losing both is 39601 over 40,000, and that gives you the same answer, 0.009975. Now, I want to do one more with you because I have seen this one on the diploma so many times. It's either they are taking 2 tests or there's 2 games going on or something like that, but I want to kind of give you the gist of this. Now, I'm making this question up as I go here, so let's do Bob. Let's do at least right. Bob estimates that the probability of passing his math test is 0.6, which is 60%, right? Or, no, let's make that 0.9. It's math. What are we talking about? Okay. And the probability of passing chem is 0. Let's go 0.5. It's a hard course. No, 0.5 is not good. Let's go 0.7 because you'll see why it's confusing if it's 0.5. So they'll just give you this, right? Now again, math, real life, you're like, geez, I wonder if you really, you know, has anyone ever, have you ever said that? Yeah, I got about a 68% chance of passing that test, right? But anyway, this guy's really good with his statistics, obviously not with his chemistry. But, so now, determine the probability that Bob will fail math and pass chem. Okay, so they always do one like this. And I hope you guys get this one just like this too, because if you're getting these tree diagrams, it's the same thing. Okay, so you have your math. And you've got your probability of passing is 0.9 and probability of not passing, that is 0.1. Now, then from here, you got chem. Now your probability of passing chem is 0.7 and failing 0.3, which is probability. Okay, and then probability again is 0.7, probability of passing chem, and 0.3 the probability of passing, failing I should say, not passing chem. So these are, because these are there's four different scenarios. You could pass both, you could fail both, you could pass math, fail chem, you can fail math, pass chem. And all you have to do is just like we've been, and they're independent. So basically he's taking the same test the same day, okay, or maybe not the same day even, but it's not like he gets his chem test back and then he goes to his other one, okay? Now, and then people could argue, and maybe they're different days. We don't even know, okay? Because people would argue same day, the first test would make you tired for the second one, okay? So maybe they're 2 days apart, right? And you don't get your other test back. They're going to be very clear that it's not dependent, okay? Now, if I was to take, so what's the probability of passing, so of math and chem? What is it? 0.63. That is 63%. So I have a 63% of passing math and chem. Now, this one would here would be probability of passing math and failing chem, right? 0.27. Okay, now what's the probability of passing, or sorry, probability of failing math and passing chem? 0.07. What's the probability of, so that's not a good day, failing math and failing chem would be 0.03. Now, if it's independent, add these up. What does it equal? Okay, this equals 1. Okay, so that's good. If independent. Now, determine the probability that he will fail math and pass chem. What is it? 0.07. Or 7%. Okay? So lay this out. And, you know, through doing obviously these 3 questions, your quiz, you know, we're going to spend 2 days on review, right? You're going to get good at these. When you get this on your diploma, okay, this will be considered a difficult question. So you got all the easy ones already. This one should be too, right? You're going to know it. You're going to, like, this happens, then this happens, right? Or this happens and this doesn't, like all those scenarios, right? Yep. And there'll be one on the quiz tomorrow, because I would not want you disappointed. So we are doing page 75 to 77. Again, please work quietly for those people that can't work with distractions in the room.